Thanks for joining, everyone. Today's webinar is a deep dive into log troubleshooting with PatchMyPC and Intune. My name's Adam Cook, and I'm a customer engineer at PatchMyPC, and here with my colleague, Olivia. Do you want to introduce yourself?
Of course, Livio, Patch My PC, customer engineer as well. Uh, just hosting this webinar with Adam. We're gonna go through over some logs today.
Let's get started then. I got quite a lot of content to get through. First is a poll. You just had a poll pop up on the screen. Please take part. We're curious to know how you use Intune today, if at all. The question is, are you using code management with Configuration Manager in Intune? It would just be great to get some insight on that. And in the chat, let us know where you are today. You know, what country are you in? What part of the world are you from? So yeah, let us know. All right, so today's webinar, this is going to be a deep dive log analysis when working with PatchMyPC and Intune. So, you know, the problem we're trying to solve here is that frequently we would get asked by customers, hey, how can we troubleshoot PatchMyPC with Intune? What does good look like in the logs? What does bad look like? What does normal look like? So we're going to go top and tail, left to right, everywhere in the logs and just kind of bump into things that we see every day. So Leview and I are going to split today's session. The things that I'm going to be talking about are server-side logs with our on-prem product, the PatchMyPC publisher. And client side, I'm going to be talking about PatchMyPC specific logs. And then there's a few common issues that Leview and I are going to round up on together. We got two each. I'm going to talk about the common issue that we bump into support. PowerShell script requirement rule is not met. Look at the logs. What does that look like? What does it mean? And then PowerShell script signing with execution policy. Going to hand over to Leview for him to give us an overview on what he's going to talk about today.
Still gonna focus on logging, but I'm gonna focus on the SaaS side. For those that don't know, we have a SaaS solution as well. So we don't, for those that integrate with Intune only, you don't have to rely on hosting the PatchMyPC publisher on premises anywhere. So we're going to focus on the logs that are available within the UI of our SaaS solution. We're going to focus on some Intune audit logs on where to find some useful information about the activity that's going on when it comes to like publishing Win32 apps. But not only that, it's going to show you other activities as well. We're just going to focus on Win32 apps today. And then, of course, some logs on the client side as well, on how to correlate the PatchMyPC installation logs with the Intune logs, what logs are interesting to you when it comes to the installation of Win32 apps and so on. So we're going to see a tad bit of the SaaS side of things, the Intune side of things, and then we're going to jump to the client side. I also have a couple common scenarios to talk about that we usually see in support. So one of them is MSI installation failure with 1603, which translates to fatal error during install. And then also a new one that starts to pop up because companies are focused on security, so they enhance security on their environments and turn on the PowerShell constrained language mode to restrict the .NET classes that are allowed to run. So that causes an issue when it comes to PatchMyPC published apps, and we're gonna discuss that and work around the fix. We're gonna discuss all of that. It's gonna be fun.
We are now going to start with the PatchMyPC publisher. I've opened the patchmypc.log. I've initiated synchronization from the sync schedule tab. This is the process of when we upload packages into your Intune tenant. I've opened the log in the window behind with this shortcut here. And the thing I was just talking about was this area of our UI. And I want everybody, if you're using our on-prem product today, to come in here and just bump the log retention to the maximum for both log retention and size, which is 10 for both. Oops, I just clicked on the wrong button. There's the most this is going to do is add 100 megabyte storage for logs, and there's just no reason not to keep more logs, right? There is an option to bump the log level to debug. I don't recommend this. Keeping it informational is good enough. Debug is, in my opinion, only reasonably good enough for developers when they want to kind of see things. Informational is more than adequate for the things that you would generally want to see, and that's where we're going to look into and focus today. So let's dive in and tear it up a bit. So let me see if I can position the window a bit so that we can zoom in and see it all together-ish. Yeah, this will do. So at the start of the synchronization, you'll always see this verbiage. The service is set to run as soon as possible, and then it kind of prints a couple of lines of underscores. this indicates the start of the synchronization. And we just kind of do a bunch of pre-flight checks. We do some testing connectivity checks to patchmypc.com. We check the license validity to make sure that your license is valid and it's the correct SKU for the integration. And you'll see that we also download a XML file, supported products.xml. You can actually copy and paste this into the browser and it will download an XML file. And that XML file is responsible for rendering all of the checkboxes in the Intune apps and the Intune updates tab. It's what gives you that presentation of software to choose from. If I scroll down a little bit more, you'll see that it tries to download to see Windows Temp. And this is true for all downloading that our solution does. It tries to download to a configurable directory in the Advanced tab. In particular, if I come to the Advanced tab here, there is not only an option for you to choose where you want patchmypc.log itself to be stored, but on the theme of downloading that I was just describing, you can actually set that temporary content download location. And it is temp here. And the reason why it was using C Windows temp in the log is because our service runs as system, and temp in system runs resolves to by default in Windows C Windows temp. You can absolutely customize that. If I scroll down a little bit more, we see some more chat about confirming our license from the previous call to do validation. It prints out our license information here. And you'll see another call to api.patchmypc.com, but this time calling a PHP file with your license key. This actually downloads a cab file. And the cab file, you'll also see, is referenced a little shortly afterwards, checking if the cab file is signed and that the cab file, catalog file is signed by patchmypc, and you'll see the absolute path where this is going to. And if we just take a look at that in program files, you will see, and this is ultimately what customers are paying for, this cab file. I'm using a restricted catalog for the sake of the demo just to make it quick, but the production catalog has like a nearly 9 megabyte XML file, and it's this XML file, which is effectively our catalog. It contains download URLs, hashes, detection logic, release notes, descriptions, CV IDs, things like that. And it's what our software ingests to go ahead and create packages in your tenant. Moving on, we see some verbiage here about understanding how many tenants we have configured in the publisher, because we actually also support multi-tenancy. And if we can also see how many products we have. And here at the very start of the sync, you'll also see the service acknowledge how many products we have enabled in the publisher. I have in the Intune apps tab, 1 product enabled, that's Greenshot. And in the Intune updates tab, I have 4 products enabled. Google Chrome, Notepad++, Oracle Java, and I think 7-zip. Yeah, so it just quickly murmurs how many products I have enabled. Talks about custom app selection. So we actually have a new feature that we released earlier in the year where we allow customers to package custom software into PatchMyPC so that they can push that into Intune. I won't talk about that today, but just know that we offer that feature. And if you want to see more, go to our website, schedule a demo. There is an option where you can have specifically a one-on-one demo about that feature, custom app packaging. And then thereafter, you'll see some murmurings about reaching out to Intune to validate the app registration information that you gave us is correct. Do we have the necessary permissions? Can we get an authorization token so that we can then use Microsoft Graph API to do everything else that we need to do? All right, so then we get on to packaging, and it starts by processing the Intune apps tab. This is one of one in the Intune apps tab. And like I said, I have Greenshot enabled, and you can see that it more or less acknowledges that I do not have this particular version of Greenshot in my tenant. So it goes ahead and creates that Intune application for Greenshot 1.2.10.6. And you'll see that it begins a download to GitHub. So a key part of our solution, if you don't know, we actually do the downloads from the internet to this virtual machine. We do the packaging and hash validation, and we upload it to Intune. So we can actually see that download start here. And we do, again, download to that temp directory. You'll see that we have a timeout called out here. So the default timeout interval for all downloads is 15 minutes. You can customize this in the registry up to a max value of 60 minutes if you're on a particularly slow download. But if this download was to exceed 15 minutes, we would abort creating the package and just move on to the next one. And at this point, you'll see copying script runner. Script runner, if you've ever looked at our packages in Intune, patchmypc-scriptrunner.exe, that is the invoking command or the executable for when we client side, the IME service starts the installation. Patchmyscriptrunner is what starts and coordinates the installation. And when it says copying, what it means is that it takes a copy from the publishing service directory. So in the install directory specifically, you will actually see script runner. And inside the .intune win will be script runner, along with some other DLLs, but also greenshot.exe. So we take a copy of it from the program files install folder. And the reason why I chose screenshot is because you will also see there's a script that being downloaded called patchmypc-stop-process.ps1. It is very common for us to include PowerShell scripts of our packages to ensure a successful install or removal of previous versions, things like that. And for Greenshot, you can actually see that script reference in our UI. If you right-click, and you'll see the option patch my PC defined pre or post script. And then you'll see the URL, the same URL to the script, the parameters we're passing to it. You can actually browse this and download it now if you wanted to, and the reason or what the script does, right? The reason why it's there. And you'll also see that called out because as we're building the .intune win file here, as you see a little bit further down after the download of the script, we take everything we've got, the exe, the script, the script runner, and at that point we're ready to create the Intune win file when we upload it and commit it to the package in Intune. You'll also see creating a PowerShell detection script. So in case you're not familiar, all of our packages in Intune use PowerShell as the detection logic. And when we create the script, we actually put a copy of it in the install directory. You'll see two folders here, detection scripts for Intune and detection scripts for Intune updates. You're absolutely welcome to go in here and look at these, but we save them to disk before uploading to Intune, okay? They are difficult to read. That's not because we're trying to purposely be obscure. It's more because there's policy constraints in Intune, and we're trying to stay within them. And then you'll see we do a download for a PNG file. This is actually the icon that users see in the company portal if you deployed it's available. So a lot of customers like that. So we do the download for the icon. And at that point, we're ready to upload everything to Intune, and we do so. We acknowledge the Intune app ID. We then upload the bits to Intune, app committed. And then you'll see some murmurings here about add category and add assignment. You'll see I have some GUID here, intent available, all devices. So if I right click on Greenshot again, two things here. You'll see that I have manage assignments configured and manage categories. For manage categories, you can actually pre-configure Patch My PC apps to be associated with an Intune package category. I don't know how else to put it really. And that was what we saw in the log. And the same is true for manage assignments. You can effectively pre-configure your assignments here for where you would like new versions of any apps, but in particular Greenshot here. So all and any new versions of Greenshot, as soon as it's uploaded, it's going to all devices and available straight away. Where are we? Yep, so we upload and then we just move on, right? So we only had one Intune app, then we move on to Intune updates. And you'll see I have a failure here. So I'm not going to go line by line for the subsequent packages. I'm going to call out now the most common failures we see in this log when working with customers. One of them is download failures. A large part of our product being installed in your environment is the fact that it is in a environment that we have no control over. So that's things like firewall and proxy. And what I've got here is a Windows firewall block on 7zip.org on their server's IP address. And that's just a key thing. The way our solution works is that we reach out to the internet for the binaries, like I said earlier, and we often see connection failures for one reason or another due to firewall or proxy getting in the way. For Google Chrome, this is really common for Google Chrome. The error that we're seeing here as we do the download, so we're trying to initiate the download. We successfully do the download because we removed the download job. But the warning is the hash of the file downloaded is different than the file hash in our catalog. So that is a very strict security procedure we have in our solution. When we download any binary, and before we put it in your tenant on this server, we compare the hash of the file that we downloaded with the hash that we know it to be from our catalog. And if for whatever reason it's different, we abort, we do nothing. And in this reason, it's perfectly innocent. There's nothing malicious going on here. This is perfectly innocent. You can see by the download URL of Google Chrome here, it's non-version specific. So you can imagine when Google release a new version, the file name is the same, but its composition changes because it is a new version. Therefore, its hash changes. Therefore, it's on us as a part of our security validation to basically update the catalog. We download the new file, we run it through VirusTotal, we check the digital signature, we do install, uninstall, and detection testing. That's the kind of procedure that we do. And this is more or less an error rather than a warning. Because what happens is that we do nothing with it and then progress on to the next package. But more often than not, in most errors of warnings, you will see verbiage that gives guidance. So like Google Chrome here, it says the hash error happens when vendors release updates that aren't available in our catalog yet. This error should be resolved in the next catalog update. And that's usually the case with Google Chrome. Notepad++, that's a good example, like we saw with Greenshot, of it going to work now. This will work as expected. This will create an update package in Intune following that exact same process. So I'm going to skip over everything else. The only thing that's different here is that I actually configured my Intune update for Notepad++ to go to 3 groups, each with different deadlines for a wave deployment. And you can see that logged here. This is the GUID of the security group in Azure AD or Entra, the friendly name, and then the intent, whether it's available or required, and it's required here. Oracle Java, this is another common one we bump into. So you'll see that we begin downloading, but of course we can't download it because this is software that is actually a local content repository product. And you'll see that it references this line, searching for a very particular exe in the local content repository, and it can't find it. And then it tells us Oracle Java 8.0.40.10.10 requires a manual download, and it tells you the exact file it needs to download. And a lot like many other lines in our log, we sometimes link out to KB articles or blogs on our website for more information, and that's true here. The requirement for Oracle Java is that it requires a manual download by customers because it's licensed or proprietary software. So what we're trying to tell you here is that the exe for this software is not in your local content repository. So please go ahead and download it by coming to the download page here and then put it in your local content repository that you see in the advanced tab. So in the advanced tab is where you configure that, like we saw in the log just now, that J local repository folder on the J drive. That's something we bump in quite a lot in support. Customers aren't familiar with the local content repository, what it is, why it's a thing, and they see this error in the log and they're not too sure what to do about it, but we bump into that quite a lot. But at that point, that's all of the packaging complete. And if we scroll on through, you'll see some murmurings of CSV files get created. Before I go any further, I'm just going to open these CSV files. Not enough customers know about this. But in the install directory, there are 2 CSV files that are often helpful for any other kind of custom automation you want to write or put around our service. You'll see Patch My PC download history. In here, you'll see a CSV file but of download attempts. And specifically, if we look at 7-zip, you'll see, looking at the code, the columns here, we have vendor, product, domain, protocol, port, reason, status code. The MSI 7-zip going out to 7zip.org failed with a status code of 999. So this just gives you a track record of what, and that's a HTTP status code, by the way, just gives you a track record of what failed or succeeded with the downloads. The other CSV is publishing history. It's a little bit further down. Much like download history, publishing history is more about what's the history of the packages we've pushed into your tenant. So if the date and time of when that activity happened, the name of the product, so Greenshot and update for Notepad++ were the only two things I pushed to Intune just now. This was an Intune app, this was an Intune update. And if I scroll further to the right, you'll see the classification of these updates, whether they were moderate. And if it were a security update and contained CVEs, you'll see that's what this empty space in the CSV is for. There's a column specifically for CSVs. So yeah, just a couple of useful CSV files there that are basically updated every time we synchronize. Every time we upload to Intune, we update these CSV files on disk, just as like a history. And then lastly, I'll round up here before I hand over to the view, is at the very end of the log, you will see a summarization of the sync. You can guarantee success or failure of any packaging. These lines will always be printed in patchmypc.log at the end of the sync. You can ignore the WSUS updates and the config-man updates. Scott, we should definitely not log these in the Intune integration. But what you'll more than likely be interested in when you're integrating with just Intune is Intune apps and Intune updates. And in fact, if you click on either one of these, it will tell you what successfully uploaded. And if I come to Intune updates, in the body of the line, it will tell you what failed as well and why. So 7-zip failed because of a download. Google Chrome failed because of a digest failure, so a hash failure. And then Oracle Java failed because the local file was missing from the local content repository. And the last thing that it does thereafter is that it initiates a self-update check. By default, self-update of the publishing service itself is enabled. And at the end of the sync that's initiated, we do a check. We schedule the next sync of when it's next going to run. But here you'll see murmurings about self-update behavior. So the service learns of if there are new versions available of the service by reaching out to this XML file and parsing it. And we just print out what's the currently installed version, what's the latest version available from PatchMyPC, and what's the latest preview version from PatchMyPC. So yeah, the self-update mechanism kicks in at the end of the synchronization. But that's pretty much a full sort of dissection of the log. And one last thing I'll call out is when you use the UI, whenever you open it, whenever you interact with anything, you'll also see logging here. For instance, when I opened the tool earlier, it told me who opened it. It prints the username of who opened the GUI of the PatchMyPC publishing service. And if I just very briefly go to the bottom of the log, and if I open the console, and if I just do the app registration test here, you'll see immediately it's printing lines as I open this window. You'll see that it just prints the result of the API permissions test. So not only will you see logging for synchronization, but you'll also see logging when you're interacting with with the console's UI as well.
Do you want to just touch base on alerts, Adam, so people don't have to rely on logs, for instance?
Yeah, absolutely. So in the alerts tab, definitely configure this if you don't already. You can be notified more proactively of failures and successes of publishing. And you can do email or Teams or Slack notifications just so that you don't have to look at the log all the time. I don't have this configured today just to keep it simple, but yeah, that's a really good shout. Thanks, Leview, for sure. But that's me. So I'm going to hand over to Leview. He's going to take the wheel for a moment and he's going to talk about cloud stuff.
So I'm going to talk about the SaaS counterpart. For everyone that doesn't know, portal.patchmypc.com. This is where our SaaS solution lives. It's just a cloud version of our core service, the publisher, our core product, the Patch My PC publisher that Adam just talked about. You can integrate this easily with your Intune tenant. You can just come here and sign up with your Entra ID account. I'm already signed up, so I'm just going to sign in. This supports SSO, so it's going to be very easy to sign up or sign in afterwards. And this is how the UI looks like. We're not going to focus on the UI today. We're just going to focus on the events. But for everyone that's not familiar with our SaaS solution, definitely go to our website. And if you're interested, book a demo with a customer engineer, and we can go over the solution in depth. For now, we're just going to focus on logs. Now, with the SaaS solution, you don't have to check any logs on the client side, right? Because this is a SaaS solution. So everything that's interesting in terms of logging or activity, you can find under the Events tab here on the left-hand side. And this will give you all the activity that's done by any of your colleagues or yourself in this portal. This logs everything. For instance, as an example here, I can see that a certain application was automatically updated by Patch My PC just earlier today. This application for a AWS command line interface was automatically updated by the schedule synchronization because the vendor released a new version. And we can see that the user will be support@patchmypc.com. So that's the user account we use when we automatically update anything that you choose to maintain in your environment. We can see whether it's an Intune deployment, it was successfully synchronized, and we can see the activity of the this event. Now, of course, if you are to choose to, the solution supports role-based access control, of course, and you can invite other users to have access to this portal. Can I draw? I cannot draw. I think my drought will kick the bucket. There we go. So you can always invite other users. And we can see when you invite another user, this log activity will be, I can see who invited. So this is my test user account. We can see that I invited this other person. And we can see that this operation type was a creation operation type. And it's a security event, right? Because we invited someone else. Whenever you deploy an actual application, so I can go to the app catalog and quickly deploy an application. I don't know, let me just choose a random one. You can just click the deploy button. You can choose the installer type. For some applications, we'll give you the choice. If there are multiple installers to choose from between EXE and MSI, you can do some customization. Again, that's not the purpose of today's demo. I'm just going to add an assignment as an example available to all users, and I'm just going to click deploy. And as soon as I do that, we can see on the deployment tab that this application is in progress. It's being packaged as a Win32 app in Intune right now. But if I go to the events pane again, we can see that this software was created by this user account. And of course, if you are to delete anything, that's going to be logged as well. You can always filter. These events will be saved for 30 days. So you can always go back for a maximum of 30 days. You can export these if you wanted to. And you can always filter out if you want to see, for instance, all events that were of error, critical, or security. You can just see all of those events. So you can focus on that. If you want to see a specific operation type, where if anything was created or deleted, you can do that as well. And you can even go further than that and see if anything was deleted by a specific user account in this portal. So you can do all sorts of filters and monitor the activity that's done by you or by fellow colleagues of yours. This is the Patch My PC portal. There are some things that you can see in Entra, of course, and in Intune itself. So I'm going to quickly go over these. If you go to entra.microsoft.com, you can monitor the enterprise applications. To allow, in simple words, to allow the Patch My PC portal to, well, package and maintain applications in your tenant, you'll have to create an enterprise application. We can automate that during the setup with a certain permission, so we can authenticate and package apps for you. And Under enterprise applications, you will find one called Patch My PC Cloud. This will have, as I mentioned, all the necessary permissions that are needed. And there are some things that you can monitor here. For instance, if you scroll down, you'll be able to monitor audit logs to see any changes that are being done by anyone in your environment, particular to the enterprise application itself. You'll be able to see the sign-in logs as well if you want to see who signed in. I'm not going to show that. It's going to show our IP address, but you can see under the service principal sign-ins, you'll be able to see that activity. So yeah, these are changes or logs related to the enterprise application itself. Now in Intune, there are more interesting audit logs that you might want to check out more often. In Intune, under tenant administration, you will find Intune specific audit logs. And if you are to check these out, they are right here. So under tenant administration, let me just do some drawings as well. You'll be able to see all of the changes, for instance, related to Win32 apps that we are doing. And here we can see that, well, earlier today, an action was initiated by the Patch My PC Cloud app, so the enterprise app that I mentioned. And we can see the activity. So we can see the categories application. This is not related to Win32 apps, not to be confused with that. It's related to the enterprise application. So it's done by an enterprise app. And of course, if you want to see more details, you can click on the activity log and you can see more details. So that we're done. So we can see here that, for instance, this time I think we packaged an app, and you can scroll down. It's a lot of data to parse through. We can see there was a new application, a new assignment. Actually, this time we can see old value was blank, and then we just set a new assignment. I'm just going to quickly make a change to show that even if you are to manually make a change, it's also going to be logged. So I'm going to go to Win32 apps, and I have an app here, the 7-zip one. Let's just take that one. And I'm going to change the properties of this app to, let's say, leave you webinar test. I'm going to save it. And then if I go back to audit logs, we should see that a user made the change, and we can see exactly, we can find out exactly who made that change. And we can see that this time the action was initiated by my user. So this is logged as such. We can see the target was this particular Win32 app. If I click on the date, I can again see all of the details with all of the changes. We can see this type. This time the type is no longer application because we didn't do it in an automated fashion via the enterprise app. It was done manually by an IT professional, so it's logged as such. And then if I scroll down, we can see that the change this time. So you'll have to have a good eye to spot these, but we can see here the old value was 7-zip. The property that changed was the display name of the software, and the new value is leave you webinar test. And if you scroll down, you'll be able to see all of the other properties like description, command, install command, uninstall command, detection script. Everything is logged in here. Of course, we didn't do any changes, and that's why there is nothing. I mean, there are no more other changes. So when it comes to monitor changes that are being done to Win32 apps, this is what we recommend when it comes to Intune. And by the way, these Intune audit logs can be checked even with the on-premise Patch My PC publisher. You're going to see activity in there coming from the publisher as well, not just from our SaaS solution.
All right,
I
cool.
think we're going to jump back to the server side logs right now, right? The client side, sorry, Adam, right?
So yeah, client side. I'm going to talk about Patch My PC specific client logs. And the good thing is that these same logs are used for the on-prem and cloud product. It's the same log, same logging, same places. So that's quite nice. And what we have here is quite nice. I have Notepad++ running in the background, and I have the notification at the bottom right for manage conflicting processes. That is a feature where we can offer a user experience where the user can choose to snooze the update. I think if I zoom, you can kind of see it. It gets a bit buggy. Zoom it is the blame there for sure. Where they can snooze the update or close. And the log of interest for client-side installation is patchmypc-scriptrunner.log. That is the log to look for. That will contain all install, update, and uninstall activity from Patch My PC logs for Intune, and you can find it here. And as a tip, I am going to very quickly take you to a web page I'm going to put a link to this in the chat. This is where you'll find all logs for our products, right? And it's broken down into scenarios. So you have two headings here, server side, client side. And then for the client side logs, today we're focusing on Intune applications and updates failing to install on client devices. And these are the logs that we would generally ask for in support. So you can use this as a guide of, in this scenario, these are the logs that you would want to look for, and this is where they'll be. So yeah, just wanted to touch on that. So let's open up patchmypc-scriptrunner.log while this Notepad++ update is trying to install by the Intune service. And let me scroll up to the top. Now you'll see the start of script runner is denoted by these very wide equals characters printed. We see the version number of script runner itself. Again, script runner is that invoking process as the install command. The version correlates with the publisher. So you'll see the same version number here tracks the same version as the Patch My PC publisher. At least that's true today. You'll see some pre-flight checks. In particular, we're identifying, what are we running the package as? In this case, we're running it as system because it's a system-wide package. If I deployed a user-based app, such as Zoom meetings, they offer a user-based product, and we have that in our catalog. This would actually print the user's name, and this would then show that this user profile is having their instance of their app data instance of Zoom being updated. And then we also print the working directory. This is where Intune downloads and launches stuff from. So therefore, this is where script runner is called from. This is script runner's working directory. And the GUID here is quite nice. This is the app ID for the Notepad++ update. And just to prove that, that's BFB078. If I come to Intune and open up this Notepad++ update, you can get the update ID just by looking in the browser once you open the package. And this update ID is honestly the best way to navigate logs in both our client-side logs and Intune's client-side logs. Leview will talk more about this for sure, but definitely put a highlight on in CM Trace for the app ID, and we'll both talk about that later. But moving on, let me zoom in again. And you'll see that update mode is requested. This is really key. This is how we can identify that this is a Intune update. If it were an Intune app, it would say something like, instead of update mode requested, it would say app mode requested or app installation mode requested. So this is how you'll be able to distinguish whether this is an Intune app or an Intune update trying to install. And then we can also finally see what it is trying to install. We name the vendor, the software name, and also the version of the package trying to install. And then the next sort of 20 or so lines are quite verbose. You don't generally need to be too concerned about the next few lines. This just prints out the arguments passed to script runner, and you'll then see script runner go through some parsing just to identify, what it's supposed to do with the installation. And you'll see some things like blocking process set to notify. That correlates with the manage conflicting process settings. I currently have mine set to notify, and that's why we have the notification at the bottom right. But I'm going to purposely skip over this because I don't feel like there's a ton of value in customers understanding that parsing activity is script runner. There's more value in understanding in this exact scenario when we have this notification open and what do we see in the logs there. So we have identified that a blocking process is running in session 2. So Notepad++ is trying to update. It's detected that Notepad++.exe is a running process. And then we can kind of see that we're doing various access controls on some other DLLs and EXEs that we've got inside the Intune Win package. And down here, you'll see that we've printed a deferral count. We've launched the process to create the notification. If you've allowed deferrals, deferrals are actually tracked in the registry. And I'm just going to very quickly show that. If you allow snoozing and deferral for managed conflicting processes, you can get the current deferral count in HQLM software, Patch My PC publishing service. Again, this is client side and UI notification. The GUIDs here are the Intune app IDs like we just saw. And if I click on here, there's the creation of when the first deferral was launched and the current count, which is set to 0. If I now click snooze to increment the deferral and refresh the registry, that now flips to 1. So we track the deferrals and the snoozes client side in the registry. If I zoom in back on this log, just to round up on here, UI notification launched, and we can see what the user chose. The user chose to ignore. They chose skip. User in session 2, and it prints the user ID. I know it says patch my PC here, but this is actually my logged in user ID. It's kind of funny, but you will actually see the username who clicked the snooze button, and then it would return 1602. And that's really important to understand. This would be acknowledged as a failure in Intune. So in that scenario where the user clicks snooze, we will send back to Intune the exit code of script runner, that is 1602. And when you go to the device install status in Intune or the user install status, it will say a user has canceled the installation with the exit code of 1602. Okay. I think there was one other thing I was going to say on that, but what I'll do is kick off the install for Greenshot. I'll have that deployed as available, and we'll take the logs for that. Take a look at the log for that. That's not any different, really, with the exception of it's going to include a pre-script or a post-script, actually, I think what we baked in for Greenshot to kill a process. One other log worth calling out, or two at this point, is software detection script.log and software update detection script.log. In our solution, you'll see that we have PowerShell used unanimously for detection scripts and also requirement scripts, and they have their own log files. And if I open up the software detection script.log, you'll see that Intune is executing that log file. Sorry, Intune is executing that detection script, and it's printing its results here. We're in that detection script, we have a logging function, and this is what we're writing. And we can see that Intune invoked the detection script at this time. We did not find it. I know it's for detection, and we looked in this registry key, and it actually ran the detection script a few times, but finally it executed it after installation. We can kind of gauge the fact that it is after installation here by looking at the timestamp, and then detection is true, and we actually found the matching registry key in this registry path here. And just to kind of correlate the timestamps here, if I put this to the left and then script runner to the right, and let me scroll to the absolute bottom of script runner where we can see the finish, and let me just reorder the columns here so I can get date time on the farthest left. The installation for Greenshot finished around about 2:50:34. And then the Intune service kicked it off, I don't know, like 14, 15 seconds later. So that just shows that it happened afterwards. But for the main meat and potatoes of script runners activity, specifically for Greenshot, what's different here? Two things. Let me scroll up to the beginning. One, app installation mode is requested. This was an Intune app that I installed, not an Intune update. So this shows that. Installation mode requested. Yep, I got that wrong earlier. Intune app ID, again, you can see it's invoking that client side in that cache folder. And then for the install itself, you'll see greenshot.exe is called. We can see all of the parameters that we're passing to it. We can see the exit code after the installation. And then we can also see the script being called. That script that we saw that was being packaged as it was being uploaded to Intune, we can actually now see it being called client side. And we can see the exit code of that script, which was success. And then ultimately, the exit code of script runner will always match that of the vendor. And what we mean is if Greenshot, for one reason or another, returned anything other than 0, script runner would always return the same, so that we're sending back accurately to Intune what happened. We're exiting script runner with the same exit code as the vendor's installer itself. Okay, that's really key to understand. We're not obscuring exit codes. We're passing that back up. But in this case, it was a success, so that's good. Yeah, that's all I have for client-side logs for Patch My PC. I'm going to hand over to Leview, who's going to dive into Intune client-side logs.
Perfect. Thanks, Adam. I'm
Yeah.
going to do exactly what Adam just said, and we're also going to try to correlate them with the Patch My PC log. So for instance, when it comes to the Intune specific logs, up until very recently, this log was relevant. And by the way, for those that don't know, the Intune management extension log, they live under C Program Data Microsoft Intune management extension and logs, and you can find all of the logs relevant there related to the Intune management extension. Up until recently, the log that was relevant to Win32 apps deployment was the Intune management extension log. Now, for those that know, this log can be immense. It contains a lot of noise, a lot of information for a lot of other components as well, not just related to Win32 apps. Now, up very recently, I'm not exactly sure when, Microsoft decided to change that. So now we can see some other particular logs, and I'm going to go through the most important ones that relate to Win32 apps. The most important log, I would say, is the app workload log. This will tell us the activity that's related to Win32 apps, like which logs or which apps are in policy, whether they install successfully, when the detection ran, when the requirement ran. If you have a detection script rule, like with PowerShell, it's going to tell us that as well, whether the application is detected or not detected. We're going to see all of this. This is just a summary. Then another log file that is really interesting, I would say, is the app action processor log. I'm just going to open this for a second. This is going to be a summary, so it's going to tell us the apps that are in policy right now. So for instance, if I just scroll up a bit, we can see that, for instance, we have this application in policy. It's a required install app. This is the targeted intent. This application is not detected yet, but it's also not applicable. So it means that this Win32 app has a requirement rule, the thing that Adam mentioned earlier. So this update doesn't apply to this device. We can see all of this information. We can see the local start time, and you can see that the year is 0001. This means you've deployed this to install as soon as possible on this device, and that's why you would see this. Finally, we can also see whether the app is well, the GRS expired, the global retry schedule. A quick note for those that don't know, when you deploy a Win32 app, if the installation fails, the Intune management extension agent is going to take a snapshot of the installation time, and it's going to use that as a reference point, and then the Intune management extension is going to retry the installation 24 hours later. Of course, the policy is going to be refreshed and checked every 60 minutes, every 1 hour, but that time is going to be used as a reference point, and only when 24 hours will pass will the installation be retried. And we can see that in this case, the GRS is expired, which means this app should be evaluated. It was, but it's not applicable to this device, and that's why it wasn't actually installed. So the app action processor is very useful to see information about a specific app. Unfortunately, the display name of the software is not shown in here, but we have the ID. And Adam showed earlier how you can get the app ID. So you can just locate the app in Intune, check its properties, and from the browser, you can just copy the app ID, and then you can come in here and search for that particular app ID to see more details. I'm going to close the log now. The agent executor will give us information about any scripts that are running. And because for the Patch My PC published apps, we use PowerShell scripts for both the detection and the requirement rule, that information on script execution will be stored in this log. We're going to open it and see it. And finally, Win32 app inventory. This is just the inventory log data. So you can see when the data is collected and set back to the Intune service. Okay, let's do a quick check over the Intune, well, not Intune, the app workload log. And I'm also going to use a real life example right now. It's not a common issue, but I'm just going to go over it and process it easier. Let's say that a user mentioned that, hey, I have this app and I got the toast notification that it failed to install. And And then you're going to use Adam's suggestion and open the Patch My PC script runner log from that device. And you can see that Notepad++, we can see it here, exit code 1618, right? So something went wrong. It failed. I would recommend then to just copy this ID, either from the log or from the Intune address bar. Just copy it and then start using the highlighter tool. If you want to have a specific color instead of yellow, you can go to File, Preferences in See and Trace, and I would highly recommend that, and just switch to a different color. I'm not sure if Adam mentioned that. If he did, I blanked out. I'm sorry. And then you can just use the highlighter tool and just paste the ID in. And then you can easily see any entries that have that ID. Now let's go back to the app workload log file and let's see what happens. Let's see what we have in there. When the logging starts, in this log, we can see here a few things. It's just preparing to start all the components, and it does some initial checks. The first thing it will do, it will check if the device is in the ESP phase, like enrollment status phase, to check if an enrollment of the device is being done. And we can see this device is not being enrolled right now. It's not in that phase. So it shouldn't kick off any other ESP-related actions. It will move on. I'm just going to scroll down a bit till we get to the interesting part. We can see again, it's not in the ESP session. So then it moves on to the next action, to the next part, and it's requesting the required Win32 apps, anything that we deployed as mandatory on this device. It found 4 results, and we can see more details about the 4 apps that it found in policy. If you want to search this specific app workload log, I would always recommend to search for this keyword, get space policies. On this log line, you will find all Win32 apps that are currently in policy on that device. And you can see details about those apps. Now, unfortunately, this log line is limited, so you won't be able to see all of the details. In that case, I would recommend you to just open the log file just for that line in Notepad or Notepad++ or anything like that. Or if you're using Support Center 1 trace, then you'll be able to see the whole thing. And I'm just going to hit Control F, and I mentioned that we're going to search for get policies. And there we go, we have the line. And here you'll be able to see all details about all of the Win32 apps that are in policy, including with their ID, version. Version means actually a revision. If the app was revised to a new version, it's going to change. So it's not the actual version of the software. You'll be able to see the detection rule. If you scroll down, this is just a partial script. You'll be able to see a lot more information. So sorry, this is the requirement rule. But you'll be able to see information such as the install behavior, whether it should install in the system context, the user context, the deadline when it should install, this is minus, and this is that time 001 that I mentioned. This just translates to as soon as possible. So you'll be able to see all of these details. Okay, now we have an app that failed, Notepad++. So I'm going to use the highlighter tool, and I'm going to paste that ID in. So let's see what information we find for this app. Some other apps are being evaluated. We don't care about those. We care about our Notepad++ that failed. So let's scroll down. We should see some entries really, really soon. Actually, I might just do Control F and just search for it downwards until we get it. I think I scrolled too much. I'm sorry, let me go back up. Did I paste the actual thing in? Okay, there we go. CM trace bug there. We can see it's starting to process this application, this Win32 app. The first thing that it will do is it will check the GRS, the global retry schedule. It will check to see if a previous install attempt has been done that might have failed. So because this is the first time the app is being evaluated, there is no recorded GRS, and we can see this on this line, no recorded GRS, and this app will be treated as expired, which means the installation should take place immediately. Now, of course, it's going to take we can see the hash for the GRS hash for this app. This is going to be documented in the registry. I'm going to show you where that's going to be saved. So then the agent just moves on. And the next action that it's going to do, it's going to run the detection rule. in our case, it's a PowerShell script. It's going to run that detection to make sure, well, to see if the app is already installed or not. So it's going to download the script because we have a script. It invokes the agent executor because the detection is a PowerShell script. It invokes the agent executor, so it will run the script for us. The script is deleted after it's the detection ran, and we have the results. We can see that this particular version is not detected on the device. Good, perfect. Then it should move on. Now, because this is an update for Notepad++, and it always installs if an older version is present on the device, it runs that requirement check to determine whether an older version is present or not. So it basically downloads the requirement script, and we can see the status says applicable. That's what that requirement script returned, which means this update applies to this device because an older version was present. After this, it will move on and download the content, right? We can see the content cache miss. It's going to start downloading the update for Notepad++. We can see it here. And it just creates the job to download the content. Once it's downloaded, it unzips the content that was downloaded in the staging content area. And then finally, once that's done as well, it should start installation. And we can see it executes retry 0. It's going to try to install the software. We can see the execution folder where the content is being cached. We can see the install command line, the update package command that Adam mentioned in the patch my PC script runner log. So it just does the installation. Now, unfortunately, we can see that this failed with 1618, the same exit code that we noticed in the patch my PC script runner. Normally, anything that's not considered, that's not 0 would be technically considered as failure. So in that case, the Intune management extension should take a snapshot and retry the installation 24 hours later. The 1618 exit code is a special exit code. And I'm going to go back to the Intune app, and I'm going to search for my Notepad app. And here, if I check the properties of this app, we have the exit codes, right? We have 0 means success. Anything that's not documented here is considered a failure. But we have 1618, which is a retry. It's marked as a retry. So anything that's marked retry, if it fails for the very first time during retry 0, during the initial install attempt, if 1618 is the return code, Intune will wait 5 minutes. So it's not going to retry 24 hours later, which is the default action. It's going to wait 5 minutes, and it's going to immediately, well, not immediately, after 5 minutes, it's going to retry the installation. We can see it right here. 1618 took place at 12:15. At 1 o'clock, it executes the next retry. So same thing. This is going to fail again in my case with, again, 1618. It's going to wait another 5 minutes. So this will happen. There will be 3 retries. So 4 install attempts in total, every 5 minutes. So then 15 minutes in total. We can see then 5 minutes later, 1:05, it does the second retry. This will fail again with 1618. We have the exit code script, the exit code here. And then again, the third retry, the 4th attempt. 5 more minutes. So 1:10, 10 minutes past 1. And again, it fails. Now, because this is the 4th attempt, the agent says, I've had enough, right? I need to do something else. I'm not going to just stop retrying the installation of this app. So right now it's removing the content from the cache. And it's cleaning up the stage content. It does a detection check. This is going to say, if we are to scroll down, it's going to say not detected, which means the installation didn't complete successfully. I'm going to let the user know that if you enable those notifications. If you don't, then it's not going to be displayed to the end user. So that's it. The software was marked as not successfully installed. At this point, the Intune management extension agent saved the value. We can see it right here. It saved the GRS value with the date and time of the initial attempt. This is saved in the registry to the path of the registry here. I'm going to open the registry. So basically that time is going to be used as a reference point. So let's quickly open the registry and correlate that data. So under HK local machine, software, Microsoft, Intune management extension, just Intune management extension, and then Win32 apps. we have the path. Let me just go back to the side a bit. So it's the path is, this is always tricky to do. This is the path xndvkm. So we're going to go to, this is the ID of my user account, and we have the GRS value, and it's xndvkm. And this is the value. And we can see it right here. This app, try to install today. Today at 6:55 a.m. This is the time in UTC. So if you have, for me, we can see it's 3 a.m., but here it says 6 a.m. This value in the registry is going to be UTC. So just don't be confused by that. The first time I looked into this, I was so confused. It took me a day to realize that it's UTC because I didn't check the registry. Here it says UTC, but I was just looking in the log file. So right now, the only option you have is to wait, and after 24 hours, the installation will be retried. If you have something urgent and you want to retry the installation without having to wait 24 hours, just delete this value from the registry. I mean, you can correlate it with the logs and just delete the key here, and then restart the Microsoft Intune management and extension service, and that's going to force the agent to reevaluate this app because there's going to be no snapshot of the GRS value in the registry. And that's how you can quickly correlate anything that fails to install, and you can correlate the patch my PC log with the Intune management extension log. Just one more quick thing. If I'm going to quickly open the agent executor log, this is going to tell us anything that's related to scripts being executed. So I'm going to paste the ID. I should still have it in my clipboard. And if I scroll up, we can see the execution of the detection or requirement scripts. And we can see it's downloading the script. It's running it. We can see the exit code. If you have certain security conditions, and Adam and I are going to talk about that, and the partial exit code, the partial script cannot run or cannot be invoked for any reason, then the exit code is going to be 0, and then that's the log file that you need to look at possible troubleshooting cases in which the software actually installs, so you can see it in unremoved programs, but it's still marked as not detected in the company portal. Then it means there is an issue with the detection, and then that's what you need, the agent executor.log. That will tell the true story of what happened. And that's me. I think we are going to jump to some common issues we see in support. So we're going to talk about those.
Yeah, absolutely. Thanks, of you. I'll start the first two, and then you'll do the next two common issues in support. Yeah,
I'm just going to catch my breath until then.
Yeah, no, that was awesome. Thanks, of you. Yeah, the whole GRS stuff in Intune was like a black box, and you did a great job on tearing that apart. You wrote an awesome blog for it on patchtuesday.com, our other platform that we use for blogging, and Scott put a link to that in the chat. It's got in the URI, it includes Win32 app retry interval. Definitely go that and give that a read. That's an equally detailed breakdown of what the view went over, and it's yeah, the retry interval is unconfigurable in the IME service. And yeah, Olivia did a great job breaking that down. Thanks, mate. Cool. So one of the common issues that we see in support is the status that you'll see on an update package. PowerShell requirement rule is not met. In particular, if you open up any update in Intune, you'll likely see at least one device phoning home with this status here. And I'm just going to kind of lay the land of what that is, what that means. So effectively, I've deployed this 7-zip update to this client device. And the reason why it's returning this state is because in the requirement section, there is a PowerShell requirement rule configured, and this is what distinguishes the difference between Intune apps and Intune updates in our solution. And the requirements script's job is, like the view said, is basically to just understand, is the update needed on a device? So on my device, it's looping the registry, understanding, is 7-zip installed? Is the installed version less than this? Is the variant installed of exe type? And is it 64-bit? Now, the confusion stems from the exact scenario I have on my device right now. I do, in fact, have 7-zip installed, and it is an old version, and it is 64-bit. But why is it returning essentially not applicable in Intune? Because that's what happens when you go to the overview stage, page or blade, whatever you want to call it. My device is showing is not applicable. The confusion here, and I wish we did a better job on this, is that I do have 7-zip installed, as seen here in the registry. Okay. I have 7-zip installed, and like I said, it is 64-bit, but it's an MSI variant I have installed and not the exe. And there's a couple of clues you can generally gauge whether software that's installed is MSI or exe. And I'm highlighting all of the key things now that indicate that this app is of MSI variant. In particular, the most conclusive way I would say is a registry value within its uninstall key must be Windows installer equal 1. And that tells Windows this software was installed using the Windows installer service, basically an MSI. And in that scenario, that requirement script returns false. And this is a huge pain point for customers because you may not necessarily know what variants of software you have installed in your devices. And then that's what leads to this confusion of like, well, I have 7-zip installed. Why is it telling me it's not applicable? Like I have it installed, but you don't have that variant, that specific variant installed. Now, the solution is basically select a matching variant, right? Go into Patch My PC, select all the variants that you know you have on your endpoints. Now, I wish we had a better way of dealing with this, and there is a feature request on our ideas portal, and I'm going to be cheeky today, exactly like I was yesterday. I'm going to put a link to this feature request in the chat. And I'm just going to encourage everyone to vote or comment on this because the solution that's being proposed in this feature request is to provide customers with an option to enforce a variant on a device. So in this scenario where I've deployed this 7-zip exe, I would like an option where I could effectively uninstall any other variants automatically and have this variant enforced on the device so that then I don't have to deal with this confusion or this. And this would definitely provide an easier migration path for customers who want to standardize on a single variant in their environment. If you want to uninstall all 32-bit software and all exe software and instead favor the 64-bit MSI instead, we have ways that customers can leverage that today, but it involves some degree of scripting. And we would love an option in our service to be able to just do that automatically, have an option to do that. So please come here. I put a link in the chat. Come vote on this. The team have indicated that I think they plan to add this in the future, but the benefit of you voting on this is that you'll get an automatic notification when its status changed to shipped. So yeah, that's something that we bump into quite frequently in support. The other thing that we bump into is the security feature in Windows. Well, not Windows really, it's built into PowerShell, is execution policy. PowerShell can be hardened, if you like, by configuring execution policy and by setting the value instead of bypass here, you can set it to all signed. And the goal is to use a machine policy and set that to all signed. That can't easily be bypassed. And you can configure that using GPO or some kind of configuration profile, I think is the right word to use in Intune, right? It's the view. You can like export the GPO and create the thing in Intune, right?
Yeah, to XML, and you can create a configuration profile.
Yeah. So if I was to try and loosely explain what is execution policy, by enforcing execution policy to all signed on your devices, you enhance their security posture by ensuring they can only run scripts, PowerShell scripts, if they are made and signed by someone you trust. And it also adds a degree of integrity checking too, by ensuring that the scripts that do run on the device have not changed since they were made and signed. So not only does it add integrity checking for who issued the script, it also adds integrity checking for that the script has actually not changed in any of its lines, its code, its functions, or whatever. It hasn't changed since it was made and signed. So it's an absolutely fantastic thing to do. If you do not enforce execution policy, highly recommend that you do. There's a little bit involved to coordinate to implement it. So don't just go and enforce the machine policy to all sign now. You have to consider some certificate requirements. So the reason why I'm bringing this up, because we bump into this a lot in support. Customers because we use PowerShell, right? In detection scripts, requirement scripts, we're looping the registry. And we typically bump into this with new customers who they're told, right, that we say, hey, you know, we use PowerShell. If you have execution policy, be mindful that you need to sign your scripts with a trusted certificate. That's the requirement, right? But during onboarding, maybe straight away they kind of they overlook that part. And I'm going to bump into what 3 of these scenarios that we see, and what those look like in the logs. So if we take the scenario where the device has the policy for execution policy set to all signed, but the script is not signed and it needs to be, what do those logs look like? So I have a copy taken from previous kind of exercises that I did before the webinar. I snagged these logs. These are Intune logs. You can find these in the exact same path that the view mentioned earlier, C program data, Microsoft Intune Management Extension Service, Microsoft Management Extension. Specifically in Agent Executor, now one thing I recommend, much like the view called out, you want the app ID in Intune like I showed you, and you want to add a highlight in CM trace so that you can easily see in Agent Executor app workload.log script runner. You can see the relevant lines because these logs are very, very noisy. Once you know the Intune app ID, the best thing you can do is set a highlight in CM trace or whatever logging tool you're using to just visually see that activity relevant to the package you want to troubleshoot. So if I just scroll up, I don't have a particularly big log here, but you'll see those lines highlighted. Now we do see in agent executor.log, PowerShell exit code is 1 and PowerShell script failed to execute. If I click on the line above, the red line, I get a verbose message and it tells me this PowerShell script cannot be loaded because it is not digitally signed. You cannot run this script on the current system. So this is the scenario where the device is enforcing that scripts must be signed, but this script that's currently trying to run is not signed. This is what that looks like. The solution here is to go to the publisher, go to the Intune apps or Intune updates tab, and select a code signing certificate here. And in our service, we will then sign all scripts with the given certificate, okay? Don't forget your devices need to trust this certificate still. And this is the next scenario that I'm going to cover. In that scenario where...
Just a quick note, Adam, sorry to cut you off.
Yeah.
Once you add a code signing certificate, it's only going to take effect for any Win32 apps that are going to be published from there on out. So any already published apps would be best to just delete them from Intune and then republish them through the Patch My PC publisher, and then the scripts are going to be digitally signed with that code signing certificate.
Yeah, absolutely. Awesome. Thanks, Avi. Yeah, the next scenario that I'm going to talk about is maybe you've gone that far to set a certificate in Patch My PC, but you've not deployed the certificate to your devices so that they trust it. What does that look like in the log? That's another scenario. That's where you're halfway there in the configuration. You've set up the Patch My PC to sign the scripts, but your devices don't trust them. What does that look like? So again, I'm going to open up this folder. Again, agent executor.log is the one with the most verbose information here. Similarly, I have the highlight. I'm going to look for that line where it tells me PowerShell script failed to execute. And if I click on the line above, zoom in on the body of the log, the log message is a little bit more verbose. A certificate chain processed, but terminated in root certificate, which is not trusted by the provider, effectively telling you that the device does not trust the issuer of the certificate. It doesn't trust the CA, or if it's self-signed, the certificate itself is not in the trusted root store, okay? Now, the third thing we bump into, and this is more offensive from a user experience point of view. Well, that's not true, not a user experience point of view. It's more expensive, more offensive from like a performance perspective when Intune is processing these scripts client side. So if you take the scenario where the script is signed and your device trusts the issuer, the root CA who issued the code signing certificate, but the certificate is not in the trusted publisher store. So the code signing certificate must be in the trusted publisher store. In that scenario, what happens? What does that look like? You're almost there with configuring it. You've configured execution policy on your devices. You're signing scripts. You've deployed the root CA to your devices. but you're missing that final piece of putting the code signing certificate in the trusted publisher store. What does that look like? And what we see here in agent executor.log, and this is the most offensive thing. Let me go up to the activity again, using the highlight here as like an anchor while I'm browsing through these logs. If we see that PowerShell process is created, and this is its PID, right? It's process ID. But look, nothing happens for nearly an hour. What's going on? Why is this PowerShell script doing nothing for an hour? These scripts take a second to run. Why is this one taking an hour? And for this, I'm going to jump to a different virtual machine. So I'm going to stop sharing now, and I'm going to actually share a different window.
I would like to note that all Win32 apps that you publish through our SaaS solution, the portion, I'm not sure if you mentioned it, Adam, but all of the Win32 apps, the scripts in the Win32 apps will be digitally signed if you're publishing from our SaaS solution. I'm not sure if you called that out, Adam. I was preparing my demo scenario, so I'm not sure if you...
No, you're good. I will totally call on that for sure. That's a really good point. So I have that exact scenario on my device here. I have this script on my desktop. And to see if a script is signed, you just go to properties and you'll observe this digital signatures tab. And you'll see if I open up the certificate, and if I look at the certificate path, there's no complaints here. The certificate is okay. I trust Adam Cook Lab CA. But the code signing certificate itself, which is named with the subject longer bits here, that's kind of like a silly testing name that I was using a while ago. That certificate is not here in my device's trusted publishers. So what's hanging? Why is it hanging? So if I just call this script that's on my desktop, this is the prompt that the user is seeing that they cannot interact with. That's a stupid thing to say. They cannot see it. This is what's happening. There is this prompt that is hidden from the user, and Windows is waiting for someone to input a yes or no on this prompt. It's warning us, do you want to run software from this untrusted publisher? It recognizes that we trust it, CA, but we don't trust the code signing certificate. And so the Intune service is in this holding pattern, waiting for someone to interact with this prompt. And of course, the user cannot see this. It's running in the system context. The window is hidden in another session. So it actually times out after 60 minutes. And this can really not slow the device, but it can certainly make the whole evaluation of the packages take so much longer than what they need to be. For what scripts should take a second each, ends up taking an hour each. And yeah, like Liv, said, this is really important in our on-prem, in our cloud solution, because in Patch My PC Cloud, we do sign all PowerShell scripts for you. We use our code signing certificate. That's been extended evaluation by DigiCert. And what you need to do if you are using our cloud solution, and only if you are enforcing execution policy to all signed, you need to deploy our code signing certificates to your devices so you can avoid this issue. Specifically, I'm going to put a link to this in the chat, or maybe my colleague can. I've lost the chat window. I'll put it in our private chat here, that maybe that's easier for you guys to get if you haven't got already. But if I scroll to the bottom, Ben Whitmore added our public code signing certificate, along with guidance on how you can actually deploy that in Intune. So that makes it super easy for you to get a hold of our code signing certificate and get it to your devices so you do not walk into this. But yeah, here's that call out in the same log file. Well, actually, the Intune management extension.log. We didn't open this on the other virtual machine that I was on, but in here you see a little bit more clearly what's going on. It tells us that the PowerShell execution exceeded the default timeout. And I ran Procmon at the time, and you can kind of see what's going on here with Procmon. When we call the process and we're in that holding pattern of doing nothing, this is all in our docs. The process is just in this waiting state. So this isn't a fault of Intune. This is not a fault of Intune. It's not a fault of Patch My PC. I would say it's a quirk of PowerShell. There is another condition when this prompt does not exist, when it should. But in any case, it's a requirement. So again, just to recap, if you have the execution policy set to all signed and you're using Patch My PC Cloud, you must deploy our code signing certificate. And if you're not using Patch My PC Cloud, you can easily specify your own certificate in the publisher. Yeah, awesome. So I think that's the two things I wanted to call out for common issues we bump into client side, I think.
So one of the common issues we see in support is when you notice in the deployment statistics, or even when a user reports that a certain application failed to install, and when you open that patch my PC log, as Adam showcased earlier, when you look at the exit code, or even if you look in the Intune deployment statistics, you'll notice that the exit code is 1603. And if you are to start the error lookup tool from cntrace by pressing Ctrl L, and if you are to just type in 1603, we'll see that this means fatal error during install. So it's pretty much useless because it doesn't give us the actual installation error or cause of the error. This error code is typically is related to MSI installers. So yeah, in such cases, you will need the vendor verbose logs to troubleshoot this. So you'll need the application-specific log to see why exactly the installation failed. To do that, there is a setting in Patch My PC, and if you haven't enabled this, I would recommend to enable this for both Intune apps and Intune updates. So right-click on all products, and there is this option here, Manage Installation Logging. If you haven't enabled this, then definitely do so. And then here you have the option to enable verbose logging for MSI installation. This will generate that log for you. Now, in my case, I did enable that. So for the software Foxit PDF reader, it failed with 1603. So we can just open that log file and we can quickly look into it. We can see in the log file, it also failed with 1603 here. And right now, all we need to do is just scroll up and find the real cause of the error. So in such cases, I would recommend just slowly scrolling because the error message might not be highlighted in red. It's only highlighted in red when there are certain keywords in that log line. It might not be highlighted in red, so just scroll up slowly but steadily and just look up for anything that's out of the ordinary. The properties entries can be ignored. They are just properties within the MSI property table. They are just being loaded, so we can just scroll up past them. And there we go. We can see action start. Foxit PDF reader, it immediately fails. A later version of Foxit PDF has been already installed. If you want to install this version, please uninstall the one that you already have installed. And this is just an example, right? In my case, for Foxit PDF reader, the vendor configured the Foxit PDF reader installer to fail to install if the user has a higher version, for instance, let's say a licensed version of the Foxit PDF editor. In such cases, you don't want to downgrade the user from the editor to the reader version. So the reader installer is compiled in such a way to just fail to install in such cases with this exit code. So the logs will tell us the story of why exactly happened. And these logs are always useful in such cases. Now, there might be other error codes, right? That are not very descriptive. This is the 1603 is just an example. For EXEs, there might be a different exit code that's not very descriptive. In such cases, again, the EXE exit codes the EXE logs will, or the MSI logs, the vendor verbose logs will tell you the story of what happened. So this is just a quick scenario of how to troubleshoot and investigate such logs. In some cases, some applications, they don't support these vendor verbose logs. In that case, always check the C Windows temp directory, because while some installers don't allow you to customize and generate logs to a specific directory, they will be generated automatically in C Windows 10. If you enable this option that I mentioned, on the client side, you're going to find these logs under C program data patch my PC install logs. So there are two folders, Intune logs, which will contain the patch my PC specific logs, but under patch my PC install logs, you're going to find the vendor verbose logs, like in my case, the Foxit PDF reader. We can see in this case, I have a Google Chrome installation log. So that's the issue number one. Now, the second issue that we are starting to see is related to the PowerShell constraint language mode. And before I talk about how that impacts our PowerShell scripts, I would like to just give a background of what this is. So for those that don't know, constraint language mode is basically a security setting in PowerShell, and it limits the commands or the scripts that you can run. it helps reduce the risks by restricting access to certain features that might be used like in a malicious way. I think in the resources we have a document to Microsoft and also a KB article on our site that will talk about the classes or the .NET methods that are allowed to be used in this language mode. The impact that it will have on our Patch My PC published apps. We mentioned several times that we use PowerShell detection scripts or requirement scripts. In such cases, you might find that all of the Patch My PC apps just fail to install, are just marked as failed. And if we are to look at the agent executor log, we mentioned this throughout the webinar, this will contain detailed information about the execution of the scripts. In such cases, we will find this error in the log line. Error from script. The term L, which is a function, I'm going to open a script to show you that, is not recognized. So again, it's not a very descriptive error message. If you are to open a Patch My PC detection script, let me just open, I should have one in my temp directory. It's going to look like this. And you'll see that it's minified or code golf, if you like to call it. Our detection scripts are done like this because of an Intune policy size issue. So that's why they're minified. If you are to try to run a script, let's see what we get. Let's manually run it, not do anything else. So I'm just going to go to C temp. And let me also actually see the execution language mode. So right now is execution context, session state was it? Yep. And then language mode. If I run it, we can see right now it's in full language. Hopefully you can see it. And let's just run that script. So if I just run it, it runs successfully. We can see it right here. It's detected. Now I'm going to quickly change the language mode from full language to constrained language. Let's confirm that this was actually applied. It's constrained language right now. We can see it right here. And let's run the same script again, the detection script. We're going to run it manually. It has nothing to do with Intune in this case. And we can see we have the exact error message. Again, it's not very descriptive. In our detection scripts, we use certain methods that are restricted from running in the constrained language mode. So if I am to just copy this part of the detection script, and if I were to run this, we're going to see a detailed error message. I'm just going to paste this, I'm going to enter it, and we can see it's explicit this time. Cannot invoke method. Method invocation is supported only on core type in this language mode. So this .NET method is restricted on this device. It's not allowed to run. The only resolution is to switch the language mode to full language. So if you're setting I don't know, a GPO using the PS lockdown policy, I think it was called, or if you're using WDAC, to set the language mode to constrained language, then all of our scripts are going to fail. And the workaround is to set it to full language. Now, again, we don't want you to lower your security. I mean, these security measures are in place with a purpose, right? To enhance your security and reduce risks. And we don't want you to reduce your security. But the KB article that we have as a resource, in that we go over in detail on an alternative. And the alternative is, I believe that Adam mentioned this, is to create app locker rules and digitally sign our scripts, as Adam mentioned earlier, by specifying a code signing certificate in the Patch My PC publisher. And in the app locker rules, you can just create an exception. So if a script is digitally signed by a specific publisher, Patch My PC or whoever the publisher of your code signing certificate is, then that script is allowed to run. Otherwise, scripts are not going to be allowed to run. And that's a good workaround. Your environment will still be safe, but you'll also fix the issue with the PowerShell scripts coming from Patch My PC. They will be allowed to run. And that way, it's just going to be happy days. All of the apps will install successfully in your devices. You'll be able to patch them. And then everything will be good under the sun again. Many thanks to Rudy. He did a great job with the KB article. We wanted to have it in time for this webinar. So he put it together. He put a workaround together. So definitely check it out. If you're planning to set the language mode to constrained language, just keep this in mind and check our blog post article.
Yeah, great session. I enjoyed that. Good job, of you. Thanks, Corey and Colin, for all your help, and Spencer and Chris in moderation. That was really good.
Not a problem. Thanks for everyone for joining. I'll wrap up the webinar, and everyone have a great rest of the day.